Hello everybody, it's me. You remember me, saw me for 2 days, so you should know me. Let me turn off this annoying beeping. I'm trying to do text recognition, which it's obviously not working. So if everything worked out right, I'm currently in Japan and you are currently sitting in class wondering what we're going to do. Well, we're going to go ahead with today's lesson. So on days when I'm out, and I will be out, I've said that already, I'll be out from time to time. Um, just listen to the sub. Sub's going to hit play or show you what's going on, and I'll go through the lesson and give you some time to work on some stuff. Again, it's the substitute's job to make sure you're doing what you were asked to do, so please be nice. She is a nice sub. I know her, I met her. She's a great person. Don't give her a hard time, okay? Just work with me, because you got to work with me. Okay, so assuming everything else worked out on Friday and there was no major emergencies or anything, because I'm recording this on Thursday for being, to be played back on Monday. So Friday we should have talked about degrees, minutes, and seconds and converting that to a decimal in just degrees, and working from decimal degrees, working backwards to degrees, minutes, and seconds. So I will quickly review that. I will also be looking at converting from degrees to radians and radians to degrees. And I'll also talk real quickly about what is a radian. Again, I should have talked about that on Friday. If not, that's okay. I'll talk about it today. And finally, we'll do arc length. And there's two arc length formulas, which you guys already know how I feel about formulas. One is for radians, and one is for degrees. All right, so we'll go through both of those and get an answer for you. So that's what we're doing today. Today is Monday, and it's going to be day 2 on the assignment sheet with the exception of number 45. We're not going to do number 45 on day 2. I'll give you some time at the end there to work on that lesson though. So let's review what degrees, minutes, and seconds. Remember what I said Friday, degrees, minutes, and seconds are nothing more than time conversions. It's just like working with time. All right, you're going to have something like 43 degrees, 20 minutes, 35 seconds. And you're supposed to convert this to a decimal. And the decimal is a fraction of a degree. So your answer is going to be a fraction. So remember, think time. It's all about time. You know what a minute is. How many seconds are in a minute? You got 60. You also know about minutes. So seconds are 60, minutes are 60. How many seconds are in a minute? 60. How many minutes are in an hour? 60. That tells you what to divide by. You're going to start at the very end though. So far for the decimal part, you're going to have 3 things. You got to do convert degrees, 2 degrees. There is nothing to convert. So the first part's easy. It's 43. All right, now let's leave 20 minutes alone. So this is step number 1. We're going to leave that alone. Let's convert seconds to minutes. So it's 35 seconds out of 60 minutes. So that's going to be the first conversion. So then you got to pull up your trusty calculator, and I'll do that with mine. Take out your calculator. Your calculator can do this too. Mine is just, you've seen this one. Hopefully by Friday you should have seen it. Don't run out and get yourself a new calculator or anything, but if you're in the market for a calculator, spend money wisely. Buy yourself a Casio. It's the only way to go. Public service announcement from me. All right, so let's do this. I want to clear all this stuff off of my calculator, so I'm going to delete all. All right, so let's convert. We have 35 over 60. That's going to give me a decimal. So we're going to write that decimal down. So far I've got 43 degrees, 20.5 583 repeating. So I'm going to have 583. You could put the little repeating bar over the top, really doesn't matter. All right, but now that's minutes. That still doesn't give me my answer in degrees. So I got to do it again. Divide by how many minutes are in an hour. Think about degrees as hours. There's 60 because there are 60 minutes in a degree. 60 seconds in a minute. 60 minutes in an hour or a degree. Same thing. So we're going to take this answer that we've got. 20.583. Divide that by 60. See what we get. There's your answer. We're going to put that right after the 43. 43 points. Bring that back up. 34305. 34305 degrees. There's a knock on my door, so let me pause. All right, took care of that. Not a big deal. All right, so let me go through that again. You started out with 43 degrees, 20 minutes, 35 seconds. 35 over 60, that gets you the first part of the decimal. Add that to the 20, just tap that on the end of the 20, and then take that answer and divide that by 60. There's your answer. Again, you can round at any point. Depends on how far you want to go. All right, so let's go the other way. Let's go new page. So let's go. This first one was degrees, minutes, and seconds to degrees. So let's go from degrees to degrees, minutes, seconds, DMS. Somebody give me a number. Come on, anybody, give me a number. Somebody shout out a number. Speak up, I can't hear you. Oh, that's a good number. 19.752 degrees. And I want to convert that to degrees, minutes, and seconds. All right, so let's do it. Now we got to work backwards. Let's work this thing backwards. Let's work our magic backwards. Let me move this number over a little bit because I can't see it currently. Let's move that over there. I could also do this. This is kind of fun. All right, that's enough of that. Alrighty, so let's convert that. So we got to work backwards this time. Last time we divided. This time we got to multiply. Again, I'm just going to take the decimal. 0.752 multiplied by 60. All right, so that's first part. 19 degrees. 45 is the next whole number, so it's going to be 45 minutes. And then this 0.12. So now we got to do the same thing with the 0.12. So we're going to take that times 60. So let's multiply the 0.12 times 60. That's working backwards there. 7.2. Okay, so it's got 19 degrees, 45 minutes, 7.2 seconds. Stop there. You don't go any further than a second. All right, so I'll review that in a second. Hold on. All right, so there we start out with a decimal. Take the decimal, multiply by 60. Just the decimal. Don't worry about the whole number. The whole number just carries on. Multiply by 60. You get some kind of another decimal, 45.12. Take that 0.12, multiply that by 60. Just the 0.12 here. 0.12 times 60, you get the answer. So this is your final answer. So that's degrees as a decimal to degrees, minutes, and seconds. All right, so radian. Let's pull up a circle here. Make a circle. Explain what a radian is. All right, so you know what a radius is. A radius is the distance from the center of the circle out to the edge. So that's a radius. A radian is a fraction of a radius. How many radiuses go around the circle? 3.14 radii will go around a circle. 1415926, or pi. So it has to do something with pi. And actually there's two pi's that go around a full circle. So full circle is the distance around the circle, which is also called your circumference. And you remember from geometry, at least you should, distance around a circle is 2 pi times the radius. Now if the radius is 1, it's 2 pi around. So 2 pi times the radius is the circumference of the circle. So if you say the radius is 1, it's called a unit circle. Unit circle has a radius of 1. So there you have your unit circle radius 1. In that case, the circumference or the distance around this thing is 2 pi around. All right, so a radian is a fraction of a circle. So what it is, radians are measures of length. A radian is a measure of length. On a circle. So, and it's based on a radius as the unit of measure. All right, so what does that mean? All right, so let's say we take this slice of pie here and we cut a 30-degree slice out of it. All right, now 30 degrees refers to the angle. How far is it from here to here? That's 30 degrees. Now, degrees are not length. Degrees are angles. So if we want to know how much is on the edge of the pie, how much did we cut off the edge of the pie? How much crust am I getting? Make this highlighter a little bigger here. Let's go nice and thick here. All right, how much crust am I getting? That's this stuff, the yellow stuff. You need to convert that to a unit of distance. You want to know distance. In order to do that, you got to convert to what's called a radian. All right, so you should remember that all the way around a circle is 360 degrees. That's the same thing as going around the circle once, which is in distance. This is in degrees. It's the same thing as in distance, 2 pi. And remember, it's 2 pi times radius. And now the radius can be anything, so the generic name we use for a radius is called a radian. And the radian can be any measurement you want. So if the radius is 3, you plug in 3 for the radian word, you get the total distance. Okay, so if we want to convert between one and the other, there's a ratio. You're either going to go degrees on top and radians on the bottom, or you're going to go radians on top and degrees on the bottom. Depends on what you want to get rid of. If you want to get rid of degrees, go with the second one. If you want to get rid of radians, go with the first one. So let's do this example. So let's say this is a 30-degree circle, 30-degree slice of pie. How much crust do we have? So we want to do radians. We want to get rid of degrees. So we have 30 degrees. I want to get rid of degrees. So in order to get rid of degrees, remember from your science classes, you have to put degrees down here. And we want to pick up radians. Now you ask yourself, how many degrees are in a full circle? Well, there's 360. How many radians are in a full circle? That's 2 pi. There you go. Degrees will cancel. Remember from science, things cancel out. Your answer will now be in radians. The zeros cancel out. 3 goes into 36 12 times. 2 goes into 12 6. You end up with pi over 6 radians. If the circle has a radius of 4, then you would plug in 4. So that's your answer for a 30-degree angle is pi over 6 radians. All right, so let's do another one. Let me grab another page here. So you have an angle, 75 degrees. You want to convert that to radians. All right, so you have 75 degrees. That doesn't change. Now you want to convert to radians. So we got to get rid of degrees because degrees are in the numerator. You want to pick up radians because that's what your final answer has to be. You have two choices here. You could go with the simplified version of this formula. Simplified version of formula is just pi over 180 because if I take 2 pi over 360, it reduces. 2 goes into that. You end up with pi over 180 degrees. And this is still radians. So you could use either one of the two. It's a formula. I don't want you remembering formulas. I want you to remember relationships. So remember the relationship. All right, so let's grab the calculator here. So I've got 75. So let me clear everything off here. 75 times pi divided by 3/6, or 180 in this case. Answer, 5 pi over 12. 5 over 12 pi radians, or 5 pi over 12 radians. It's the same thing. That pi can go up to the numerator. It does not go in the denominator. It always goes up. All right. So that's converting angles, degrees to radians. Let's go backwards. Let's go from radians to degrees. Use the same logic. Don't change the way you think about the problem. The problem works the same. Doesn't matter what it is you're working with. So let's take 14.5 radians. I want to convert that to degrees. All right, so you got to get rid of this word radian. So you're going to put a radian in the bottom, and you're going to put a degree up top because that's what you want to pick up. Your simplified version of the formula is there's 180 degrees in 1 pi. You could do 360 over 2 pi. Does not make a difference. Now the word radian cancels because that's what happens. You got numerator, denominator, those go away. Pull up your calculator. 14.5 times 180 divided by pi. So it's 830 point stuff. Or you could have done the divide by pi and leave the pi in there. So let's say we've got 830 and some change. 7, 8 repeating. Doesn't repeat a lot, but it repeats a little bit. And that's degrees. Or you could just do, let's multiply the numerators. (2610) over pi. Oh, that doesn't look like a 10. Let me change that. (2610) over pi radians. It depends. Either one of those two answers is fine. My calculator could have actually done that. If I'd have gone 14.5 times parentheses fraction 180 over pi on the bottom. Oops, put the parentheses at the end here. Alright, so the answer's the same. Alright, let's see, what else am I supposed to do here? So we did that. Arc length. Arc length. Let's talk about arc length. Arc length, which we kind of already touched on. We touched on this idea when we talked about radians. If you take a circle, I'm going to take a slice of the arc. I'm going to start here. You want to go to there. You want to know how much arc did I cut out there? What's the arc length? There is an arc length formula. Again, it's a formula. I really don't like formulas. The formula is arc length, which is abbreviated S, equals R times theta. Now, theta is the angle. Remember, that is theta. Theta is an angle measure. R is radius. Radius times that arc length. Let's say that's 145 degrees. Actually, it's got to be more. It's more like 195. Let's go with that one because it's more than half a circle. So here's my disclaimer. Don't believe your lying eyes. That's 195. Even though it doesn't look like it, looks like it's more than that. But let's just go with 195. All right, so let's do it. The radius. I need to know the radius of this thing. Let's say the radius of the circle is 4. Arc length S equals 4 times 195. Okay, we still have a problem here though, because this answer is in degrees. So 4 times 195 is going to give me some kind of a weird degree measure or something or other. So I can't really do that. Theta here, since we're talking length, has to be in radians. So let's do some little conversion here. Conversion's not difficult. The 4 doesn't need to be converted because that's already length. I got to convert 195. 195, that's degrees, so I got to multiply that. Now remember, it's just like you did it before. You want to get rid of degrees, so degrees go on the bottom. Put 180 there. Pi up top, that's radians. Now we are talking length with length. Before this was length and degrees. Length and degrees don't make any sense. That measure has to be in radians. So don't forget that. So now everything is in the proper units. Take 4 times 195 times pi. Divide by 180. 13 over 3 pi. Use parentheses if you have to. So if you have 4 times parentheses 195, close those parentheses, times parentheses pi over 180. You could just divide by 180. Answer's the same. All right. If the measurement's already given to you in radians, let's say the arc length, let me go to a different page. Let's say I have a different type of problem. Let's say I've got a problem like this. Let's say I give you the arc length. Let's go with a nice highlighted yellow. Let me give you an arc length. It's this yellow part of the circle here. Yellow is pretty bad because it's hard to see. So let's go over it in pink. All right. So let's say the arc length there is 13 centimeters? Okay, you have 13 centimeters. The radius of the circle is 3. What is the central angle? How big is the central angle? Remember, central angle from geometry is the distance between how big that angle is from the center based on the center of the circle. All right, so we know how far that is sketched out. Remember, it's easy. Keep thinking that. S is arc length equals r times theta. Remember, theta must be in radians. Your answer wants to know in degrees. So we know the answer in degrees. So let's plug in what we know. What we know is it's 13 centimeters equals 3 times some angle in radians. Some distance in radians. All right, so this distance in radians is 13 over 3. So then we got to work it backwards. Well, if we work it backwards, I think we're going to get the same thing we got before. Remember, this measurement is in radians, so you got to get rid of radians. Well, actually, it's going to be a little different because there is no pi in this one. Pi has already been multiplied in. So you have 13 over 3 radians equals theta. Now theta is in degrees I want. All right, so let's do this. We're going to multiply by 180 degrees pi radians. Radians will cancel. So let's see what we get. We got 180. I need some fractions here, so let me get some fractions. 180. Up top, on the bottom, you got pi. Close those parentheses. Times parentheses. You're going to need 13 over 3. Let me delete that. Let me close it out there. Get your answer. 248 degrees. 248 and some change. 0.2817 degrees. All right, so there you have it. You just work it backwards. You know this formula. You know what you need to do to get there. All right, so what does that mean for your homework? Oh, I know you can't wait because you did 1 to 23 already. So let's see, we're supposed to look at 2 degrees, minutes, seconds. You know how to do that. 8 decimal 2 degrees, minutes, seconds. You can do that. We did that already. Number 12, convert degrees, minutes, seconds to radians. So you got to do some conversion to a decimal first and then convert that to radians. You can do that. That's a simple 2-step thing. 25, let's see what 25 is about. That's 24. Let me move this out of the way here. 25, okay, given this information, what is S? And again, it's given to you in radians already, so all you got to do is multiply these two together. S equals R times theta, and theta has to begin in radians, so you can do that. The simple one, man. 27, same thing. Now you got to figure out what R is. Plug in the formula and solve. You just got to divide there. It's already in radians. 29, again, same thing. Find radians. 31. Ooh, you're given to it in degrees, so convert that degrees first. All right. 31, 33. Same thing. Given one radius, given a second radius, given one arc measure, second arc measure, find theta. Two concentric circles with radius 1, radius 2. So concentric circles, remember, are two circles that have the same center. One may be bigger than the other one. So if you want to draw a picture, I would draw a picture with two circles. 35 to the nearest inch, find the perimeter of a 10-degree sector cut by a circular disc of radius 11 inches. So 10-degree sector, work that out. Should not be hard. We'll take a look at 35, 37. Territory cars. All right, we'll take a look at 37 also. 39. 39 is not bad. It's compass reading. How many degrees are each one of these? You cut the thing into 1, 2, 3, 4, 5, 10, 15, 20 sectors. That's my phone ringing. I'm not going to answer it, but it's going to keep ringing in the background. So that's not hard. 43, let's see, are we doing 43? No, we're not doing 43. 43 is about statute miles. We didn't talk about statute miles. You don't need to know about statute miles. If you want to, you could read about it, but unless you're sailing. If you're sailing, you already know about it. And then 45 is a good one too. So we're going to take a look at two of them in the time we've got left here. So we're going to take a look at 35 and 37. To the nearest degree, find the perimeter. Let's see if I can copy this. There it is. So let's see what we can do with this. To the nearest degree, to the nearest inch, sorry, to the nearest inch, find the perimeter, that's distance around, of a 10-degree sector cut from a circular disc of 11-inch radius. Alright, so we need a circle, obviously. There's your circle. 11-inch radius, let's give this thing a radius. 11 inches. 10-degree sector. 10 degrees. Find the perimeter. Oh, guess what that is? That's arc length. So now you know what to do. S equals R times theta, and remember theta must be in radians. So you got to convert 10 into radians. So S equals 11 times 10 times. We're going radians. We have to go to get to radians, so we need radians up here. So that means pi is there. 180 is degrees, and those degrees will cancel out there. Do some multiplying, see what you get. 37. Copy, let's paste that. Let me blow this up a little bit here. Takes 10 identical pieces from a circular track. For part of a toy race car, the inside track measures 3.5. Shorter than the outside. What is the width of the track? Alright, so we're looking at a circular track again. And it's got another track, so we need two of them actually, because it's inner and outer. It's like racetracks when you're a kid. There's two circular tracks, so that's what we've got. That's what we're looking at anyway. 10 identical pieces to form a circular track. So this thing's cut into 10 pieces. 2, 3, 4, 5, 6, 7, 8, 9, 10. Hey, there you go. 10 identical pieces. The inside arc of each piece is 3.4 inches shorter than the outside. What is the width of the track? How wide is the track? All right, so we don't know what this arc length is from here to here. That's x. The inside is going to be x minus 3.4. Ooh, wait, hold on, that might not be it. No, that's it. All right. What is the width of how wide is this track? All right, so let's figure this out. 10 pieces, which means 10 arcs, all the same. So if there's 10 pieces, each piece is cutting 36 degrees. Because if you take 360 divided by 10 pieces, each one of these is being cut by a 36-degree angle. All right, so now we've got to figure out what that is in radians. So we're going to go 36 degrees, pi over 180 radians again. That's radians over degrees. Those cancel. This is going to give me a radian measure, whatever that turns out to be. The arc length is r times theta. Did I miss anything on that one? Well, we could do that. Oh, what else does it say? Let's see. That's not going to get me anywhere, so let's keep going. 10 pieces, 3 point... Ooh, I get it. Okay, so the full circle is 2 pi all the way around. Divide that by 10 pieces, which turns out to be what? Pi over 5 is the outer piece? Let's just say that for the outer piece. That's pi over 5. All right, so that's outer. The inner is pi over 5 minus 3.4, but that's not the whole thing. I still got to multiply by whatever the radius is, remember? So it's radius times pi over 5 is the same as the second one, which is the radius of the second one, times pi over 5. This is radius number 2. This is radius number 1. But I've got to add 3.4 to it to get it where I want it, because in order for these two to be the same. All right, let's get our R1s and R2s together. R1 times pi over 5 minus R2 times pi over 5. This is outer, this is inner, equals 3.4. Now if I go outer minus inner, that's the difference, so I'm almost there. So if I take outer minus inner and factor that out, I get 3.4. All right, let's just do some dividing here. The difference between R1 and R2, which is the length of the track, or the width of the track, is 3.4 over pi over 5. Lo and behold, do some magic. Turns out I think it's like 5.4. Just did that on my calculator on the side here. So it's pi over 4. All right, so that's that one. So we'll give these a